Well, hey, today we got kind of an exciting concept here. We're looking at a scatter plot here, a bunch of data that's been collected and spread all over the place. This has to do with roller coasters and a relationship between the top speed and the maximum drop. And as you can tell, it's kind of all over the place. And we're going to look and create a linear model on this because we can see that it's not a linear relationship, but we can put a linear model on here to help us make good predictions. And so one of the first things I'm going to do, I'm going to take a look at the whole data relationship here, and I'm going to see that it goes up. So I can start by putting a line together here, and I can see that it's going to go in an upward motion, maybe like right here. And I might move that around a little bit to kind of see. I'm going to keep drawing lines. I don't want to do that, so I'm going to kind of move that around because I want it to go right kind of through as much of the data as possible. And I think I did an okay job at that. Okay, and because I put one on here, doesn't mean that yours will be exactly the same. Linear models, everybody has a little bit of a different one, but they're all going to be kind of similar. Okay, so now that I have a linear model, I can then make an equation to this. Okay, and so my equation is going to be y equals mx plus b. And there's a couple elements here. I'm going to go ahead and grab the y-intercept. And so I'm going to look down here, and there is my y-intercept. And it looks like it's about 28, 27 or 28. So I'm going to go ahead and pick 28. And this is an about right now. I could calculate this using a formula, but right now I'm just going to use this. And for my slope, my m, I need to find a couple of points. Oh, this happens to go through here, and it happens to go through up here. I'm going to use these 2 points. Now notice neither of these points that I've drawn are actually data points. Like there's no data on these, but what they do show me is that they're where my line is, and that's what I want to work with. So a couple things. My slope is rise over run, or you can look at it as change in y over change in x. So I'm going to do that. It goes up, and it actually, even though it looks like it's going up 2, it's not rising 2. My interval goes by 10, so it's rising 20. And it's running 1, 2. I'm going to look at my interval and see what it is. And it looks like it is going by 40s each time, so it is 80. So it's 20 over 80. And I'm going to simplify that down a little bit more as 2 over 8. And that simplifies down even more to 1/4. So I can use that to then create my equation. Y equals my slope, which is 1/4, x plus my y-intercept, which is 28. And I get my slope from my rise to run, and I get my y-intercept from where it crosses the y-axis. I hope this helps you kind of getting an equation to a model. All right, I'm going to go bake a cake out of mayonnaise.